We've got about 100 expectant South African librarians in the room here. My name's Alistair Cook. I'm the Regional Sales Director for the American Chemical Society. And we're very pleased to be able to sponsor the gala dinner here today at the SAP meeting. It's obviously a shame that you couldn't be with us in person, but it's kind of a little bit more authentic actually to get you beamed in, given what may be ahead of you in your future career. Dr. Adriana's academic background is at the University of KwaZulu-Natal. She's currently, correct me if I'm wrong, you're head of innovation for SAP.
SAP Africa, yes.
Yeah, I think you're about to tell us you're involved in a very exciting project about leaving the planet and starting to colonize the rest of the solar system that we currently live in, and potentially even further and beyond that. So I'm going to hand over to you, Dr. Adriana, just to maybe go through your slides and tell us a little bit more about yourself and the project you're involved in.
Thanks so much, Alistair. Hello everyone, I'm currently in New York, so thanks so much for this opportunity. Sorry I couldn't be there in person, but glad that I still have the opportunity to share my story, so thanks so much to Glenn and the organisers for putting this together. So indeed, let me start by saying as a child I used to read a lot, as I'm sure you did in your current endeavours, a lot of books, and always dreamed that I was rather born in a different era. So I dreamed of being an Egyptian queen, or longed to be a Greek Viking warrior, or to have really lived in some more interesting era than the one I found myself in growing up in the 1980s in Pietermaritzburg. However, I have now changed my mind because I believe this is not only the most exciting era for humankind, but in fact for life on Earth, because in the sort of 4.1 billion years of lifespan evolving on this planet, there's extensive evidence now that life was around as long as 4.1 billion years ago. This is the moment, and we're alive now to be witnessing this moment where a living organism, or a species of living organisms on Earth, mainly humans, have developed technological capability to propose to move life off of planet home, planet Earth, for the very first time. So I will talk a bit about that today, and also relate that back, if I can, to some of our activities here on Earth at SAP Africa, because I think this is all pertinent for the theme of knowledge creation, innovation, caused by exploration. So I'll talk about that in more detail. So I'll talk about settlement of Mars. I think future on Earth is an even more challenging question than whether or not we'll settle on Mars. So I'll go through why I believe that. And in the end, I think why my real motivation for exploring, which is really to create knowledge, which I think we all have as something close to our hearts. So I'm a quantum physicist, and there are some things that I need you to understand before we can go forward. So if we could just... This is the slide of quantum mechanics, don't worry. We're not here to study maths, but we are here to think a bit about the big picture. So for me, the big picture starts with the very small. How small is very small? Well, to be very small are the smallest objects that we know of. So namely, photons, which are point-like objects, electrons, which are point-like objects, atoms, which have size but are very small. So let's sort of see how small that object in the middle there is. A human hair. That's a micrometer in width, approximately. If we go 1,000 times smaller than a micrometer, we get to the nanometer scale, which is a DNA molecule, obviously the molecule underpinning all life on Earth, or at the center of life on Earth, is a couple of nanometers wide, 2 to 3 nanometers wide, of course very long, but 3 nanometers wide. And if we go then below the nanoscale, we get to the regime where electrons, atoms, molecules interact, and quantum physics describes very well what happens here. So you may be wondering what this has to do with you. Well, in fact, development of computing. So any device that performs computing, your smartphone, your computer, increasingly other devices in your house, actually use quantum physics to operate. So semiconductivity is a quantum mechanical principle on which transistors are based. So this is a quantum mechanical property that we've harnessed to do computing. So any device that you have is in fact using quantum mechanics. Our communications right now are somehow using quantum mechanics. So in fact, my research focused on a different application of quantum mechanics, not to computing, but to biology. So interestingly, living systems kind of operate in two worlds, let's say, in two realms. In the classical world, of course, which is the one we're familiar with, where we can sort of see objects and touch objects and predict using classical physics what happens. If we go down to very small scales, we find that photosynthetic complexes can only be understood in their functioning by using quantum mechanics. So things like quantum coherence play a role as bacteria, algae, plants, anything that performs photosynthesis, absorbs sunlight and turns that into useful forms of energy for the functioning of the organism. So of course this is fascinating from the perspective of understanding nature, but importantly it also has implications for our technologies. So if we can understand how biological entities absorb sunlight with almost 100% efficiency, which they do, we can perhaps use sort of biomimicry is a good way to explain how we are kind of trying to understand and copy natural processes to improve the performance of our devices. And we're all aware of how important using solar power will be in the upcoming years due to various issues that we have running out of fossil fuel, climate change, etc. So the fact that engineers are now working on the research that myself and maybe a few hundred people around the world are working on to try to build devices was a comforting thought for me, and I immediately moved to the next big question, which is where did photosynthetic complexes come from? I mean, the earliest fossil evidence of life that we have seems to be photosynthetic, and where did these photosynthetic organisms come from then? They appeared on Earth sort of 500 million years after the formation of the planet. How did they form? Where did they come from? And at the heart of it is this question then, what makes a bunch of molecules different to a living organism? So it's quite clear how to turn a living system into a bunch of molecules. That's called death. But how to turn a bunch of molecules into a living system is not something that we really understand. We don't understand how it happened, and we don't know how to implement this ourselves either. So one problem with trying to understand life is the fact that we only have one system to study. So of course, you know, from a scientific perspective, you need at least a few data points before you can start to come up with a general theory. And at the moment, we have just one data point. Life on Earth is all related according to genetics. With very high probability, we all emerged from some single universal common ancestor. So if we could find an example of life somewhere else, that would provide another data point, another reference frame for us to understand, you know, the general principles of life and how it may have emerged. So looking for life elsewhere is the fascinating field of astrobiology, amongst other aspects of the field, is the search for life. So let's remind ourselves now that the universe is a huge place. We're all aware of that, but let's run through some numbers to remind ourselves. So that first object there, I'm sure you'll recognize as Mars. Let's measure the distances to these objects in light years. So Mars is around 10 light minutes away. That means, light being the fastest object that we know of, takes around 10 minutes to reach Mars. So that's a communication delay of around 10 minutes. That's a fundamental limitation to communications on Mars. So if you send me a WhatsApp message when I'm on Mars, to say, oh, well done for making it, we remember your presentation in Durban back in the day, it will take 10 minutes for that message to reach me. So live Skype conversations like this one now is not something that we would be doing on Mars, but of course video clips can be exchanged. But 10 minutes, that's how long light takes to get to Mars. The next object there is Proxima Centauri, the nearest star. Light takes around 4 years to travel from that star to Earth. So if you download the Sky View app, which I really recommend, one of my favorite apps, you can, in the day or the night, point your phone in different directions and it will tell you where and what these objects are that you're looking at. So that light, those photons of light coming from Proxima Centauri to your phone have taken 4 years traveling through the vacuum of space to reach your smartphone. That's how far away the nearest star to our sun is. That next object, that's an artist's impression of Kepler 452b, one of the thousands of exoplanets that have been detected in the last few decades, really 2 decades, before which we weren't certain whether other stars really had planets. Now we've detected thousands of them, and this is one of the most Earth-like ones ever discovered. Earth-like, we think, because it's orbiting at a distance from its sun, similar to that at which Earth is orbiting. Its size and so on, its mass, estimated mass, are relatively similar to Earth. So this is a fascinating one that we want to investigate further. The problem is getting there. I mean, that's light. That takes 1,400 years to get there. So even if we devised some intergenerational mission that finally arrived there some 100,000 or million years later using currently existing propulsion technology, the message that these people would send back to Earth would take 1,400 years to travel the distance between that planet and Earth. So the vastness is starting to settle in now, but we're still in our galaxy, by the way. If we leave our galaxy, the Andromeda galaxy is 2.5 million light years away. At this point, analogies start to fall flat, but we're nearly at the edge of the universe, and that's almost 50 billion light years away. So the context in which we find ourselves is really an immense space. Yeah, we battle to understand our own lives sometimes, never mind what's going on in the vastness of the universe. But the point of this slide was really to remind you of the vastness, but also to convince you of the comforting, familiar, neighborly, and really a natural location to explore, which is Mars. If you're the kind of person who wants to go somewhere where no one has gone before, a 10 light minute distance away is really a familiar, neighborly place to go and visit, and that's the plan. So of our two neighbors, Venus and Mars is a more natural candidate due to several factors. I won't go into details, but Venus is really hot and has sulfuric acid rain. So that's some of them that would make it rather unpleasant and difficult to survive there. But I'm happy to answer questions afterwards. If your question was, really, you want to move to Mars, I can answer that now. Yes, and I'm not alone. There are 100 of us in the final round with the Mars One project. 2 of us are actually from SAP. So that's 2% of people trying to leave the planet, and I think that's not an indication of job satisfaction, but of our levels of curiosity. So I really think all of us are inspired by curiosity, and if it's the unifying factor amongst all these 100 people, I would say it's the desire to extend and expand what we're doing here on Earth, and indeed not at all to leave behind what we've been doing on Earth, but to continue, expand, extend, imagine, dream, and continue our endeavors on another planet. So the Mars One, I'm going to mention several projects after this, but this is the Mars One plan, or outline, to settle humans on Mars within a decade, around a decade. I mean, this has never been done, of course. The last time we were on the moon was 1972, so dates are to be viewed as flexible here. Yeah, so around a decade, let's say. The technology will be outsourced to companies like SpaceX, Boeing, Lockheed Martin. NASA outsources launches to SpaceX increasingly, so this is a natural way to do space travel nowadays, is to have a collection of engineering companies putting together the hardware together. Of course, you need money to fund such a mission, so where will the money come from? Well, from you, in fact. Not directly, actually, but simply through watching the reality or documentary TV series that will accompany the selection of the 24 from the 100, which will be taking place probably next year. The training of these 24 for 10 years, and the departure of the first 4 in around 10 years' time. Will all be part of this documentary series, as well as the landing on Mars, the living on Mars, the expansion of the settlement on Mars. Over the next few decades, you have some fascinating TV in store. I think people are still watching Big Brother. That is always fascinating. I have no doubt in my mind that this will be more interesting. So, and in fact, that will generate the funding. So, the Olympic Games generated around $10 billion in broadcasting revenue alone. So it's true that having 7 billion people with increasing access to devices and internet can generate on the order of tens of billions of US dollars in broadcasting revenue, and this is of the same order of magnitude required to send humans to Mars. Probably more than 10 billion, but that order of magnitude. Mars One has announced in March this year that they're now valued at $400 million on the Frankfurt Stock Exchange. Disturbingly, this is about the same as Justin Bieber's total net worth. Also, unfortunately, this is not enough to get to Mars yet, but this is definitely a step in the right direction, so we're excited about this. So Mars One has been accused of being a hoax, a scam, a scandal, a joke. All sorts of bad press came out in the beginning. I think that's the risk that you take when you're a true pioneer in proposing something really novel, really unique. However, since then, several other companies, private companies as well as NASA, have announced plans to send crews to Mars. SpaceX, at the moment, has pitched their date first in 2025. They will do a cargo mission launch in collaboration with NASA next year, if all goes according to plan, and then become the first private company to land cargo on the surface of Mars. Boeing wants to beat SpaceX. Lockheed Martin wants to put like an international space station in orbit around Mars and having crews living permanently there. NASA wants to send crews in the 2030s. So these are all return missions, by the way. The Mars 1 mission is a one-way mission, as you might have heard, not because we want to go there and die, but because we want to get there first. Start to set up the settlement, which many others will be arriving to if all of these plans go according to schedule.
It's March 30th, 2017, 6:08 p.m. Eastern, 10:08 p.m. UTC. You're looking at a live view of a recovered Falcon 9 rocket on the SpaceX launch pad as it awaits its second launch since landing back in April 2016.
So in case you didn't catch this revolution in space flight, this was on the 30th of March this year, implemented by South African born Elon Musk's company SpaceX, founded in 2001 with the sole mandate of expanding humanity off the Moon. They are making leaps and bounds in this direction by having performed the first this is the separation phase. So the rocket is going to be re-landed. So in fact, this rocket, so I'm not looking at me and the cheering in the background, but this rocket was re-launched after having been landed previously.
Stage on its way back to the drone ship in the Atlantic Ocean, slowing down as it enters the atmosphere. Second stage continues to be on target. Propulsion looks good. Everything continues to be go.
So this rocket is going to land on this platform, but this is the second time that it's done so. So this is really demonstrating reusability of rockets. This is stage one, the extensive levels coming down real time. Never get tired of watching.
We just had an incredible day today. The first reflight of an orbital class booster did its mission perfectly, dropped off the second stage, came back and landed on the droid ship, right in the bullseye. It's an amazing day. I think it's really a great day, not just for SpaceX, but for the space industry as a whole, and proving that something can be done that many people said was impossible. Thank you.
So I really believe we are living in an era where the distance between the dream and the reality is increasingly small. That's because of technology. And it's risky to say something is impossible nowadays, especially with people like Elon Musk around, because the impossible is being demonstrated every day right before our eyes. This is a revolution in spaceflight because it will reduce the costs of launching by more than 50%. Of course, being able to reuse a rocket, imagine how many of us would have flown in an airplane. Airplanes were used once. It would be an elite group of people, just like astronauts who have ever traveled in one. So now that we are able to launch at sort of 50% or less of the cost, I think the whole new economy in space is going to open up. Exploration is going to boom like it hasn't since the 60s and 70s. And South African born Elon Musk has made it possible. Some people say I'm brave to have volunteered to go to Mars, but I really believe that early explorers are far braver than I am, because we have a very clear idea of the environment that we're going to. We're not exploring with complete lack of knowledge of the place we're going to. We have information due to scientific missions that we've been sending to Mars since the 70s, observing Mars and collecting data and sending it back to Earth. So we know, especially because of the Curiosity rover, which is currently on Mars with the laboratory on board. You can follow the Curiosity rover on Twitter, by the way, in case you're curious what it's getting up to, minute by minute. Of course, we're in 10-minute time delay, but the Curiosity rover is tweeting, well, I guess the human is tweeting for it, and sending back data that it's collected on Mars about the temperature. On average, around negative 50, negative 60 degrees Celsius, because Mars is further away from the sun than Earth, and also has a very thin atmosphere, so it's not very insulating. Atmosphere is 96% carbon dioxide, and the pressure is less than 1% of Earth, so that's similar to being 30 kilometers up into the stratosphere. It's less than 1% of sea level pressure. So even if there were oxygen in the atmosphere, you wouldn't be able to breathe it because of this very low pressure. So yes, we will minimally need helmets, we will need suits, we will cold when we go outside. Inside it will be temperature regulated, oxygenated, and pressure regulated, so that it will be clothing. Mars is red because of the rust or iron oxide, and is a large component of the surface sand. And the gravity on Mars is around or just over 1/3 of the gravity on Earth. So if you can pick up one of your friends on Earth, you can pick up 3 of them on Mars, and the construction becomes easier in this reduced gravitational field. We'll probably get slightly taller because of this reduced gravity. Also live longer because, as you can see, birthday will only come around every 2 years. If you want to get taller and live longer, Mars is a good destination for you. Real life expectancy on Mars is something we don't know. The radiation is, of course, helpful. In some sense, we will live underground, in fact, to protect us from the radiation. But of course, we will make trips outside regularly as well. So how the human body will respond to this environment in the long term is really something that we'll discover as we go along. So the technologies required, first of all, the satellites will be set up. So in case you had a question about how we will communicate, whether we will have internet, yes, we will have internet. We'll have 2 satellites for 4 people. The 10-minute delay exists, of course, but between 4 people, 2 satellites. On Earth, we have around 1,300 satellites for 7 billion people. So yes, we will have good communication capabilities. And this will be the first part of the mission, in fact. The second part will be sending remotely controlled rovers to collect water. Several months of water will be stored in tanks before the humans even leave Earth. Several months of oxygen, which is extracted from the H2O, will be stored in tanks before the humans even leave Earth. And the habitat will be partially constructed by the rovers so that the humans will arrive to drinking water, some kind of habitat in which to sleep on the first few nights before constructing the rest, and oxygen on supply, and solar power, of course, for the warmth and heat and powering the systems. So as I said, there's water on Mars, which is really crucial. I don't think we would not be able to create a sustainable settlement on a planet or a body that doesn't have water. Water's heavy. The liquid water that 4 people will drink during the 7-month trip there is 3,000 liters. It's just over 2.5 liters per person per day. So this is a huge part of the mass that we'll need to take with us, and on arrival we will have to be extracting it. So Mars is feasible for habitation because of the 2% mass water that the Curiosity rover has detected in every location. Looking at some artists' impression of how Mars may have looked billions of years ago. Some of the water remains, although a lot of it has evaporated off the surface. Mars has undergone extreme climate change in the last few billion years. We will 3D print our electronic components, our habitat components, probably our clothing, maybe even our steak. And we won't, of course, have any cows on the planet initially, or ever. So 3D printing is a hugely important development, and the volcanic activity that was previously present on Mars and the cratering are regions of previous heat where the kind of minerals and ores that we would need to print with will be found. And Mars being a terrestrial planet, it has many of the same components and the surfaces as Earth has. So we'll be growing our own food, of course. It will take maybe a year or 2 to get the greenhouse up to the point to support 4 people. We'll bring backup food with us, of course. And basically, I think that if we can survive on Mars in this hostile environment, I think the main endeavor for me is to prove, in principle, to people living on Earth that there is no longer any excuse for the poverty in which so many people live on Earth. Earth is a relatively easy environment to live in. We can breathe the air, we can drink the water, plants grow themselves. On Mars, everything will be an ecological miracle, pretty much. And I think that this will be a perfect sort of case study for how we should be living on Earth. We should be using solar power. We should be using water as a very precious resource. We should be maximizing and optimizing our indoor farming to support the growing population that we have on Earth. So that kind of brings me back to the sort of last third of my talk, where I will talk about the future of life on Earth, because I don't know if I've had enough time in these last few minutes to convince you that humans will be living on Mars in the next 20 years. I truly believe that we will. I'm sure I will be one of them, but I believe we are going to see this grand effect take place in our lifetime. What is not clear to me is what the future of life on Earth is. How will we sustain our growing population, given that we have finite resources on this planet? This, for me, is a far more complex question than how a couple of people will manage to survive the harsh conditions on Mars with the technology that we're bringing. This is an answerable question to me. The question of Earth, I really don't know what the outcome is. I don't think anyone knows. It's a complex problem, it's a complex system, but one thing that is true is that we have finite resources on Earth. It's the closest. Another fascinating question is how will technology develop? I think we need to focus on how we will shape technology and not be worried about how technology will shape us. Although when computers become more intelligent than us, this will really be a strange world in which we find ourselves if we are still alive at that point. So I think we need to harness technology to answer the former question, and that's why I'm really excited about my role at SAP, to look at how we can use technology, especially in the African context, to make people's lives better. So I hope that we have some volunteers in the audience from tonight to come to Mars. The more the merrier, of course. My point is that we don't need to travel to different planets to explore. We can explore from our borders, from our neighborhoods, from our countries, from our continents. We can explore reality by looking at smaller dimensions. So the miniaturization of technologies is really the result of exploring the miniature parts of reality. So quantum computing, nanomedicine, all of these miniaturizations and our understanding of things on a smaller and more molecular scale is the result of exploring reality, the reality of the very small. And many interesting technologies will come out of that. On the other hand, I think space is really the next frontier in terms of the next big economy. It's an area that's going to be more accessible thanks to developments like that of SpaceX. And I think, I don't need to tell you after showing you that video that exciting things lie ahead in terms of our activities in space. But so I think if I look at our projects at SAP Africa, they kind of can be divided into these two categories, looking at smaller, more optimized, efficient processes, and also looking at grand asteroid mining and big data astronomy type endeavors. So I'm not going to spend too long on these projects, but I think it's really interesting to think about between the kind of technologies that will be essential for life on Mars and those same technologies role on Earth in terms of making people's lives better by using our resources more efficiently. So that's the Durban Stadium, as you'll obviously recognize. And back in 2010, the Tekwini municipality implemented quantum encryption in the stadium. Our research group from UKZN encrypted all of the communications, the CCTV, the verbal communications, the text communications, etc. of the dignitaries arriving and the players and so on, using quantum encryption. So I think Durban should be proud to have done that back in 2010, because this is something we are only now beginning to discuss at SAP, the third largest software company in the world. So I think the African context, being less risk averse, I would say, has really a lot to offer to innovation on a global scale. I'm not sure if you've heard about the world's first drone port planned for Rwanda. So SAP hopes now to do logistical software infrastructure, kind of like air control in an airport, or kind of like monitoring cargo in a port. So this is a drone port, the same software basically, just adapted for this new scenario where medicines and other small packages can be delivered, circumventing the poor road infrastructure by drones. Another interesting project is desalination. I mean, the paradox of Cape Town suffering a lack of drinking water. We're having two oceans present, really. I think we need to work on something on desalination. People say that it's expensive, but it's with developments like graphene-based sieves and using solar power to power these kind of plants. I don't think that's an excuse any longer, and we hope to be involved in some desalination plants. This picture might look familiar from Mars. I mean, this is something we can do on Earth. Indoor urban stacked vertical farming can use 95% less water than traditional agriculture, and then the fresh produce is in the urban area already, so the time from production to retail can be reduced to a few hours if you're growing the food in the city in the used urban spaces. So this is something else we're looking at, and of course collecting data from these sensors that are put in such a greenhouse. We'll be able to optimize then exactly how much nutrients, water, sunlight, etc. different species of plant need. Blockchain is an exciting one, which I won't go into now. I could talk for a while on that, but blockchain for land claims is an interesting project that we're working on in the South African context. So this is an exciting one, and using software, we are doing a cost estimate of how much it will cost to extract platinum from asteroids. I think the mining industry is going through a difficult time at the moment, also because of increased legislation, and I think this is a good thing. Earth being the only planet we're aware of that has life on it, I don't think we can risk disturbing ecology at the rate that we have been doing when there is also platinum available in rocks floating around in space. So the next $1 trillion industry in mining could possibly be off Earth. And I'm sure you've heard of the square kilometre array being constructed in the Northern Cape. This will be the world's largest data generator. 160 terabytes a second is the same data currently moving around on the internet right now, per second, on the global internet. This will be generated by the single radio telescope in the Northern Cape. So SAP is hoping to help to come up with new software to visualize and analyze and distribute these huge amounts of data. So I think for me the most profound possible outcome of the settlement on Mars would be to detect signs of extraterrestrial life, possibly in fossils or maybe even still living beneath the surface. But I think life is the most interesting question, whether we're looking for evidence of ancestral life to life on Earth, or whether we're thinking about how we will live, the legal issues, the societal issues, the cultural issues. What will this new society on Mars be like? And I think perhaps the explorer in me is in my DNA, which is what my mom had pointed out, because our ancestors arrived in the Cape in 1688 after a 4-month one-way journey into the unknown on a ship. And I think there are so many parallels between this embarking on a journey to a new land that has in common with the Mars project. The distance is of course uniquely far, but the story is not unique in human history. This is what we do. We explore, we dream, we imagine. And I think imagining and exploring is a way to future-proof ourselves. So most species that have lived on Earth have gone extinct because the environment changed and they couldn't keep up. Humans have technology and we have the capability to dream. And when we can imagine scenarios before they happen, we can prepare ourselves. And if we think that we are worth saving, which is a question I'll assume that we say yes, then we need to start thinking about these future scenarios and how we can protect ourselves against them using our technologies. So that's all for me. I think that creating knowledge is for me the most exciting and profound contribution that my life could have. And doing that from Mars would be a unique opportunity to create new knowledge, completely new knowledge. And that's my motivation for going, curiosity and the desire to create new knowledge. So thanks very much for your time.
Wow.
Thank you, Dr. Adriana. That's absolutely fascinating presentation. Thank you for sharing that with us. We're going to take a roving mic around the questions to ask you. I've got maybe one just to kick things off, which is in terms of when you were told your family, your friends, your colleagues that you were going to possibly be taking a one-way mission and not coming back, how did they react?
My mom actually reminded me of the conversation that we had when I said right at the end, oh, by the way, I volunteered to go on a one-way trip to Mars. And she said, oh, will you have communication? And I said, yes. And she said, oh, okay. Chat later then, bye. I had to Google it because she wasn't quite sure if I lost my mind or not, but that was really her question and still is, and she thinks that it can be something she can handle as long as we can be in touch. My dad has said, of course, that not being able to hug each other would be a sad reality, but they visited me when I was in Japan, and I do hope that with the increased lifespan and increased technology, that one day if I do make it to Mars, they'll be able to come and visit me there. My friends, of course, thought this was a completely fitting move for me and made a lot of sense, not because they want to get rid of me, but because this is exactly my cup of tea.
If it was my choice, I would with you. However, just because we can go, does that mean we should go? You know, we've made such a mess of this planet. As you say, you know, we're not doing very well in fatal desalination. We're not doing so many things. What gives us the right to go and damage another planet?
So, as I've said, I hope that demonstrating livability on the surface of Mars will be an inspiration of how we could be living on Earth. So I think the fact that Earth is full of life, this is the planet we should be protecting. Mars does not appear to have a lot of geological or living activity on it. So exploring it and understanding how we can protect our own planet would be the motivation for that for me. So it can help us to appreciate our planet. I mean, sometimes you only appreciate what you have when you really leave that place and understand what the other options are out there. So looking back on Earth from Mars, I think might be the moment when we finally really appreciate what Earth holds. And yeah, I think being able to extract resources off of Earth and then protect the ecological systems on the surface of Earth would really be one of the motivations for expanding our industries off of Earth, to leave the natural ecology on Earth be, and to do our mining and our industries off of Earth. I think that could be an option.
Yes. Hi. Sorry, can you hear me? So, firstly, that's amazing. It's
stand up, please, so that she can see you.
super. So, firstly, it's amazing. And my question to you is: you said you read a lot when you were a child. Who's your favorite science fiction author and why?
So I mean, Asimov, Arthur C. Clarke all come to mind. Actually, The Martian would be my most recent famous, and I think that's closer to science fact than science fiction. But if you've watched the movie The Martian, I highly recommend to read the book. The author actually publishes it free online, so you can download the PDF. A really well-researched book. I think the degree to which it's fiction, as I said, is debatable because it's a really realistic scenario. But I think the stories of Arthur C. Clarke that are sort of imprinted in my memory from childhood are probably the most powerful stories that I've heard in that scenario. Philip K. Dick, of course. Yeah, Do Android Dream of Electric Sheep? Another favorite. Yeah, well, thanks for that question. I need to go reread some of those.
I've got two questions. You said you're planning to colonize Mars. Does that mean that children will be born there and society will grow? And how many people do you expect to eventually have living there? And the second question is, what if somebody decides they want to come back?
Yeah, that usually happens with one or two in the group. So the plans for the Mars One project are to send the minimal model. So a one-way trip, just a team of 4. A team of 4 is the minimum team size to have enough overlapping expertise so that if something happens to one of them, you've got a backup, etc. There's many articles written on this. That's why 4 is the minimum team size. And a one-way trip is, of course, the minimum economical model, the cheapest way, in other words, to get there. So that's the Mars One project. And then they plan to send another 4 people every 2 years. So the window of launch to Mars, which is the most cost-efficient way to get to Mars, opens up every 2 years or every 27 months. So that's the plan for Mars One. Elon Musk, on the other hand, plans to have a city of 1 million people on Mars within the next 50 to 100 years. NASA doesn't plan to stay there permanently ever. They plan to do return trips all the time. So Boeing and Lockheed Martin, I'm not sure the details of their plans, besides being in orbit, or Boeing hasn't announced any firm plans. So I think we can compare for the next 50 years what will be on Mars to Antarctica. So probably mostly research scientists, probably no children being born there, and it will be more like a scientific outpost where we're really investigating and experimenting with how to best survive there. But when the society reaches sort of 500 people, which is also the critical mass of diversity and DNA required for a sustainable population, around 500 apparently from what I've read. So I think when you get to a few hundred, then perhaps you could start to justify the time required to raise a child and the resources. And at that point, the first Martian may be born, but probably in my lifetime it would be more like a research outpost.
Thank you, really interesting talk. Do you think there's kind of a risk that people think, oh, never mind, we're going to Mars, so never mind about Earth, we'll get it sorted in Mars? That kind of skeptical thought process has the ability, I can imagine the news media would say, it's okay, we're going to Mars, we'll colonize that, don't worry about the Earth, and that would cause detriment. Obviously you're looking to advance science, but how would you as a group of intelligent people address that question?
So thanks, yes, that question does come up a lot, but for me that isn't really the question in my mind, because we're not leaving Earth because we're destroying it. We're leaving Earth to try and come up with new ideas to help to fix what we're doing here on Earth. We're not escaping from Earth at all. In fact, we're trying to expand our knowledge, expand our understanding of our context in the solar system in order to appreciate and treat Earth better. So as I've said, I hope that the kind of technologies that we require to survive and sustain ourselves on Mars will be useful back on Earth for being more resource efficient, for raising people's standard of living, for optimizing farming, for being able to produce food and clean water in difficult environments. So that's the motivation for me. I don't think Mars will ever be, I don't think by showing you these photos of Mars that most of you are convinced that that would be a fun place to live, and I think that will remain the case. Mars is not going to be better than Earth. It's going to be for those people that are doing research or want to explore or to devise something new or create new knowledge. I think breathable air, drinkable water, and an ocean to swim in will still be the Trump planet. Oh, wrong word. Sorry, wrong word. I don't think that living on Mars is ever going to be a lot more comfortable than living on Earth, but I think for those of us who feel like we want to explore further, the kinds of knowledge that we create will be useful for life.
I think we have time for one more question.
You just mentioned that every 2 years there will be a succedence of further people potentially going out, and almost like a longevity plan that there will be with year after year, or every couple of years, more and more people going out. I guess my question to you then, based on that, is, what was your motivation? If you take it right back to basics, this is a big decision. As you said, it's a one-way trip. There's no return journey. This is clearly your passion, clearly your life. You emanated. It very clearly comes through in everything that you've said tonight and your entire presentation. So, at what point in your life, what made you get so excited and so passionate about this, that made you make this decision?
So for me, I didn't even make the decision. The moment I read that headline, before I'd even finished reading the text, and I read it in the newspaper the old-fashioned way, every single molecule in my body froze, and I said, this is what my life has been gearing up for. This is what I'm going to do. It wasn't a matter of weighing up, whether life on Earth or life on Mars would be better. I think no matter which era I lived in history, if I was around when Columbus set sail, I would have made sure to get on that boat. If I was around when the first people wanted to go and explore Antarctica, I would have jumped on that boat. Then it was boats, now it's spaceships, and I think I've got that personality type where if people are going where no one's gone before, I will not stop at anything to be one of them, because I want to see that with my own eyes. I want to walk there with my own feet to experience something completely unique and to contribute to knowledge that will help people all over the solar system. I think exploration does drive innovation. After the moon landing, we saw an increased number of students and PhDs in science, technology, engineering, and mathematics. And not coincidentally, statistics show that the invention of the mobile phone, the PC, the internet, resulted from this cohort of students studying science who were inspired by humans landing on the moon. So I think this kind of exploration will just stimulate imagination, create new knowledge, and just be a celebration of what it is to be human. I know that probably 99% of people would rather celebrate this adventure from the comfort of your couch watching it on TV at home. But for me, there's absolutely no other alternative for my life that I would choose over being one of the first humans to move to another planet. That's taken 4.1 billion years of evolution to get to this point. I just can't believe my luck.
Just one final thought before we wrap up, Adriana, is I've got maybe a slightly less serious question, but I presume you'll get a little bit of downtime on the 2-year or so flight out to Mars. What will you do on your downtime? Do you have a lot of David Bowie songs that you're listening to, or?
Yeah, Space Oddity is a bit of a depressing one, because I try not to listen to that. Yeah, David Bowie's written some awesome space-themed songs. Certainly music, we'll have, I guess, a few terabytes of stuff that we can take with us, watching reruns of the Big Bang Theory. We could learn each other's languages. I mean, the crews of 4 will be as diverse as possible. I hope they aim to have each person from a different continent, culture, language, profession. And we'll all be trained in the essentials, of course, but with different backgrounds. So learning each other's languages would probably be a good idea. And we'd be going through all of the necessary, going over again and again how to fix, maintain, and control the equipment that we'll need when we get there. And of course, just writing poems about being the people who've traveled the furthest from home ever.
I think we're going to wrap up at this point. Just before we do, I'm just going to put my shameless plug in for the American Chemical Society, because we agreed to sponsor this gala dinner, obviously mainly to support the Stanley Conference. The other part of the attraction for me is ACS has just launched a brand new journal. The first issues are coming out, and the title is American Chemical Society, Earth and Space Chemistry. So I thought that was quite relevant. And you know, what we have here is a room of people who are publishers, information professionals, people who are involved in our bit towards, you know, improving knowledge dissemination. So I think not just for ACS, I think from our community too. I think, you know, we're contributing hopefully a little bit towards the you know, the fantastic enterprise that you're in the beginning parts of undertaking. So, you know, thank you for joining us today. Glenn, I don't know if you want to.
Adriana, just from my side, thank you so much for faithfully coming to the party. Thanks a lot. Enjoy Planet New York.
The joke that I know about Mars is this librarian's son came home and had an astrology assignment to do, and he asked his father, Dad, the librarian, where's Mars? And Dad said, the librarian said, ask your mother, she hides everything in this house. So that's the only thing I know about Mars.